So, hi everyone, and welcome to my talk, or this kind of like interactive session, which I've called Dr. Strangelove, or How I Learned to Stop Worrying and Love the Learning Outcome. And so I'll first apologize. I've kind of seemed to have caught something at the ELIXIR-UK All Hands or slash the traveling, so hopefully my voice will hold out. But if I'm sounding a bit gravelly, that's why. I'm not intentionally doing the vocal fry. So, learning outcomes of this interactive session is to understand the use and benefits of learning outcomes in higher education. It's to explain the difficulties of creating learning outcomes, know the categories in Solow and Bloom's taxonomy, and apply the Solow and Bloom's taxonomy to learning outcomes. And then finally, once we've applied, we'll create learning outcomes with the combined Solow and Bloom's taxonomy. So a bit, I'm sure some of you know this, but it's always good to have a reminder. Why learning outcomes and what are they? So there are a list of statements learners will be able to carry out after a course. It kind of started off with the Bologna Declaration in 1999 to promote quality assurance and greater comparability and compatibility across Europe's universities. So the idea is to provide overview of what will be gained to the learners, such as the skills, the knowledge, and the competencies. So that's kind of the fancy stuff. But I always find them difficult. I find it difficult to create them, and especially I come from bioinformatics. It's especially challenging from computer science. And so generally you're always taught in, I know in my PG CAP, postgraduate certificate of academic practice and all the kind of things I've learned about pedagogy, they teach you Bloom's taxonomy. But with that, it's hard to determine Bloom's taxonomy level to use for computer science. And even the second author, Bloom's, finds it difficult to use. And so one of the big issues with learning outcomes is that it can lead to demotivation if students don't meet the learning outcomes. So if they come to, if they learn, they see those learning outcomes and they feel like they haven't actually reached all of them, that can be quite demotivating to a learner. And so solutions, and this is one of many solutions, the solutions that I'm going to teach you, but obviously there's many different ways to do the same thing. But I like this method. It's to create learning outcomes with a combined Solow and Bloom's taxonomy. And important for this is to choose realistic levels for the topic and students. So the lower the level of your learning outcome, the more you protect from failure if the students don't reach them, because it's easier to reach lower levels. However, you want to have a higher level to promote deeper cognitive processing, but don't choose complex levels to increase perceived value of teaching. So in essence, get it just right. Obviously, easier said than done. And so finally, let's talk about the Solow and Bloom taxonomy. This is specially designed for computer scientists. We are using 3 out of the 4 Solow levels, which is the unistructural, the multistructural, and the relational. And then we're using only 3 of Bloom's subcategories, which are understanding, applying, and creation. And this gives you 9 paired combinations. So unistructural with understanding is one, unistructural with applying is another one, etc. And of course, this isn't my idea. This was published by Masapanta Carrion and Velasque Utubide. I hope I pronounced that correctly in 2018. And so a bit more about the Solow taxonomy. So the Solow taxonomy, we have our 3 levels. We have the unistructural. This is the local perspective. And this is mainly one item or aspect emphasized and others are missed. We have the multistructural, which is multi-point perspective. So you have several relevant items or aspects, but significant connections are missed. So you're not seeing the whole picture. And then you have the relational, which is the holistic perspective. This is the meta connections are grasped. And so you get to see the significance of parts with respect to the whole, which is demonstrated and appreciated. And so this is very useful in this is all in the document we'll be looking at today for like kind of group activities. And then of course there's Bloom's taxonomy. And so with this, we're only going to use 3 levels as kind of the default. And these 3 levels for coding are understanding, applying, and creation. So you can kind of think of like understanding how to use code, applying that code, and then creating your own code is kind of the way I like to think of it. But of course, we can still use remembering and analyzing if you feel that's appropriate. And the kind of main idea, I always find it hard with Bloom's taxonomy is you get the different levels and it's like, here's all the different verbs you can use, etc. And that kind of overloads me and I'm kind of like, which one do I use? And my language sounds a bit off. And so I'm going to say, use the words you would use naturally. And I think especially with computer science, that is easier or than kind of other more theoretical stuff, such as when you're using biology or even literature. And so let's look at some learning outcomes that you'll be interrogating yourself. So here's Intro to Linux learning outcomes. And this is, it's quite nice. I have lots of workshops. And so I've just taken the learning outcomes I actually have for this workshop. So if you have any recommendations, that is, will be useful, but we'll talk about that later. And so here's the learning outcomes I have. Explain how the user, shell, and kernel interact with each other in the Linux OS. Navigate and manipulate directories in the Linux environment, list and view the contents of directories, carry out a variety of commands with files, including printing them to terminal, utilize the text editor Nano to create, edit, and save files, and then understand the structure of FASTQ files. And so that's kind of most of what I'll be talking about now. Instead, we're going to move on to use and in groups. And there's about 15 of you, so probably 3 or 4 groups, I would say. Um, and so you're going to first apply the solo and bloom levels to the intro to Linux learning outcomes. So those learning outcomes I've just gone through, you're going to go on Teams and you're going to actually say what levels of the solo they belong to, or at least you think they belong to, and which level of the bloom they belong to of those 3. And on the Google Doc that we'll be working through, it kind of shows that. In fact, let me show you. So you have this learning out, this document here. You'll see you have Dr. Strangelove, we have the solo and bloom, you have the solos here, the bloom, and then for the first task, you're going to pick one of these teams. And I said 5 teams maximum, so please choose one. So Croc team, Triangle team, Cloud team, Clover team, or Kiwi team, and we'll ignore Pizza, Anchor, and Football team. Um, and yeah, and then so you'll go on to it and you'll see you have your 6 different learning outcomes and you'll be writing down what of the 3 solos you think they belong to and which of the 3 bloom they belong to. And so I'll let you do that for 5 minutes. Then we'll return for 5 minutes. We can kind of discuss and share understanding. And then that's us applying. Then we'll be creating. So I've got some other workshops. So I've got QCR Python. We'll kind of divide into teams. You'll pick a workshop. So let's say QC, and you will make learning outcomes for this. This kind of gives you a bit of an idea. So sorry if you don't know too much about bioinformatics. Hopefully, we'll get some people who know stuff, know well enough, and slash I can kind of help, or you can Google, and then you'll try and make some learning outcomes based on the solo and bloom taxonomy. But that's for later. For now, we'll do the applying the solo and bloom levels to the intro to Linux learning outcomes. So does anybody have any questions? Okay, grand. So let's go on to the second task. So this is definitely a harder one. I'm not expecting you to make all the learning outcomes, even if you make, so let's have a look. Yeah, so we're going to split you into 3 groups again, and you're going to create learning outcomes for 2-day bioinformatics workshops. So hopefully everyone will have at least 1 or 2 bioinformaticians in each group, which will have an idea. And you're going to choose one example kind of workshop to join. So that we have Intro to QC, Intro to R, Intro to Python, 16S, Bacterial Community Analysis, Shock and Metagenomics, RNA-seq, and Genome Assembly. I picked these ones because these are ones I have. So, and hopefully it gives a good breadth of, so people will be able to choose one. And if we look at this, you can kind of look here, and if you pick one of them, you'll see that you can put in the members, and here's kind of the info. So, and you can add in more, but these kind of give you bullet points to then create learning outcomes from. So you have theory of Illumina sequencing, errors in Illumina sequencing, FastQC and multi-QC. And again, maybe just choose 2 or 3 of these. And if you can maybe make a fourth, great. But we're probably only going to have about 15-ish minutes for this. So yeah, 2 or 3 learning outcomes. So I guess yeah. So does anybody have any strong um, inclination of what they would like to do? And then they can kind of get team members to join them. Okay, so we're waiting for some more people to join. I think, yeah, room 1, room 3, I guess, still chatting a lot, which is good to see. But I hope you all find that somewhat interesting. For me, it was I just for a long time I didn't bother because I didn't need to. I didn't bother making learning outcomes because I really didn't like just the Bloom approach. And oh, that's I think everyone back. So yeah, hi everyone. I hope you all find that interesting. Hopefully some of you will use this and hopefully some other people are like I prefer the way I'm still doing it and that's grand as well. Um Before we chat a bit more, we have feedback form that you'll kind of once you leave the room, you'll get a bit of a feedback form. We very much appreciate everyone filling that in. That's super useful to know that people are engaging in this and we should, keep it going. And the other thing is on the agenda in minutes, at the point 2, we have the introductory presentation, the teamwork tasks, but then we also have a linked test. So these are the events that United Kingdom does, and they have all my NEOF workshops there. If you go on to one of those NEOF workshops, so if you were in the R people, there's the R primer for omics is there, and you can actually see what my learning outcomes were, just if you're interested.